So now we're going to be talking about async computation. You will have heard the word async probably thrown around like at least 20 or 30 times in the course of Web Lab. And we've always been putting it off, like, what is async? Why does it need to be this way? What is exactly going on behind the scenes? But today is the day that you actually learn what async is and how to deal with it. So let's start off with just talking about like, what is synchronous computation versus asynchronous computation? So synchronous computation means something just happens consecutively. So like you have a line of code, you run that line of code, and you go to the next line of code, you run that line of code, you keep going, and just in order. On the other hand, asynchronous computation just happens at some future point. So we don't really know how long it might take. It might take, 1 second, like it might take 10 milliseconds. It might take, like 10 hours. We don't know. So we just say we're going to start it now and it'll finish sometime later and we'll just figure out what we do when it happens. So that's the main difference between synchronous and asynchronous computation. All right, so let's give a quick example. So let's say we have, Alan Jing here. It's like a really hot summer day. So like not right now, but like let's say it's during summer. And he's feeling, he's feeling the heat and he wants to get, he sees an ice cream truck. So he might think, oh, I want to get an ice cream cone. So let's say he says, I want five, or he thinks I want 5 ice cream cones because it's a really hot day. He just wants a lot of ice cream, right? Or 5 snow cones. So he goes to this ice cream truck and he asks the ice cream truck, can I have 5 snow cones? The ice cream truck says, okay, I don't see a problem with that. And they start working. So the ice cream truck is, in the back, they're like mixing their ice cream or they're making the snow cones, grinding up the ice and pouring stuff on it. And Alan is sitting out here waiting for a little while. After like maybe a minute, the ice cream truck gives him his first snow cone. It's like, here you go. But there's still some more stuff they're making. So maybe after a little while, they make the second snow cone, and then the third snow cone, and the fourth snow cone, and the 5th snow cone. Now the ice cream truck is done with their snow cones, and Alan has all 5 snow cones that he ordered. All right, sounds good. What if there is more than one truck? So let's say this time Alan is outside on a hot summer day, and there are 3 ice cream trucks that pull up. And he still thinks, I want 5 snow cones. So what does he do? Well, there are a couple options here. So, he can go and ask the first ice cream truck, hey, can I have 5 snow cones? And, the first ice cream truck does some stuff. And after a little while, they gave him 5 snow cones. That works. But maybe he can do better than that. So he can go to the first, or if he thinks he wants 5 snow cones, he can go to the first ice cream truck and say, hey, can I have 2 snow cones? The first ice cream truck says, okay. They start working. They're making their snow cones in the back. Now he goes to the second ice cream truck. He says, hey, can I have 2 snow cones, please? They say, okay. They start working. All right, now he goes to the third ice cream truck. Hey, can I have 1 snow cone, please? And now they start working. And so Alan's waiting for a little while. The first ice cream truck makes their snow cone. The second one makes their snow cone as well. And then the third one, and the first one makes their second snow cone. The second one makes their second snow cone, and boom, Alan has all 5 snow cones. Now, generally, this is like faster because, each ice cream truck only has to make like 2 snow cones at most instead of all 5. And we'll talk about like, how this works in actual code. But what you just saw here is an example of promises. So promises are the key concept in asynchronous computation in JavaScript. So a promise is an object in JavaScript. It is like just like any other object, and it represents some asynchronous task. So this means something that will happen at a future time. We don't know how long it'll take. It'll just happen over some time. Now, promises have 3 states. When you first make that promise, it is called pending. So pending promises just mean, you're waiting. You don't know if it's done. You don't know if it's not done, whatever. You're just waiting. Now, the promise can be fulfilled, in which case it's completed successfully. So you got your result back that you wanted. So it's fulfilled. And the third case is the promise can be rejected if some error happens or just you can't do it for some reason. So these are the 3 states that promises can be in. All right. So if we go back to our snow cone example, we can see, Alan asked the ice cream truck, hey, can I have a snow cone? In this case, the asynchronous function is the ice cream truck making a snow cone because it takes some time. We don't really know how long it'll take. Alan is standing there and he calls the ice cream truck. He says, hey, can I have a snow cone? That is a call to this asynchronous function. So basically just ask the asynchronous function to do some stuff later. When the ice cream truck says, okay, I'm working on it, that means the asynchronous function just returned a promise. The promise is, I will get you a snow cone at some future point in time. It's like, I'm going to make my snow cone right now and I'll get back to you. So it returns that promise immediately when you call it. So like when Alan says, can I have a snow cone? The ice cream truck will immediately say, okay, I'll get you one. So that's the promise. Now, while Alan is waiting, that promise is pending because he doesn't have the snow cone yet. The ice cream truck is just sitting there. It's working. It's trying to make the snow cone. So the promise is pending. Once the ice cream truck is done, it will give Alan his snow cone. So that task is finished, right? The making the snow cone is finished. And the promise has what we call resolved into an actual value. And that value in this case is what the snow cone or the ice cream truck has made. And that is the snow cone. So the promise is called fulfilled, or it's resolved into the value of this snow cone. Now, an alternative way that this series of events could have played out, Alan asks the ice cream truck for a snow cone. The ice cream truck makes a promise. It says, okay. Now the promise is pending while Alan is waiting. And let's say it's like 4 p.m. The ice cream truck has run out of ice. It says, sorry, we don't have any more ice. We can't get you your snow cone. Better luck next time. In this case, the asynchronous function ran into an error, which means like there's just no ice. You can't do anything, right? So it can't fulfill that promise. And that is what we call a promise that has been rejected. So Alan is never getting a snow cone, and he's sad. But yeah, so that is the sort of core idea of promises. That is what all of asynchronous computation is going to be built upon in JavaScript. All right. So what does that actually look like in JavaScript code? Well, if we look at some of this stuff that we saw in workshop 3, I believe this is, somewhere on the front end. Like you might have seen these use effect hooks like everywhere. So if you look at this use effect call, we're going to focus on a specific thing, which is the get/API/stories function. So what does this get API stories actually return? We've kind of been saying like it gives you the stories, right? It calls the API, gives you some stories, and then you can use .den and whatever to like do stuff with it. But what does the get function actually give you? Like what is the thing that actually gives you? So in this case, I've rewritten it slightly. If you look back, like it uses .get and then .then some stuff. But in this case, I've just taken that get function and sort of isolated it, and it said const stories equals get API stories. So I'm just defining what that thing is, that variable, and I'm going to console log it. Now it turns out if you have VS Code, and I believe some other editors do this as well, if you actually mouse over the stories variable in your code editor, you will see something like this, where it says, it has like a little bar that says const stories and then promise any. This is in VS Code, but I think some other code editors do this as well. So that promise any is just VS Code's way of telling you that this variable you have defined has a type which is of promise any. Now the promise just means it's a promise, as you just sort of mentioned. The any in the angle brackets means it's going to resolve to something, like anything, and VS Code currently does not really know what that anything is, but it will resolve to something. And if you actually run this little thing and like have the console log run it for you, it will log something like this on the bottom where it says promise pending. So that kind of shows that, right after you call this API call, you try to print out what you get back. It is a promise that is currently pending. So it doesn't have its result yet. Okay. So we can handle promises with .den and .catch. We briefly mentioned this earlier, but now we're going to go like more in depth into what these things actually do. So once a promise is fulfilled, the .then function takes that prompt or takes the output of the promise, like the value that it resolves to, and then it runs a callback function on that value. So in this case, we call get API/stories that gives us a promise, and then use .then. Let me draw some boxes. Use .then, and then that takes it to the stories object. That's a value that we get out, and then that is that has some function applied to it. And in this case, that is, set stories, story objects. So essentially what we do is the .then function just waits for the promise to fulfill. And once it is fulfilled, it will do that function to the output. So that is what .then does. And notably, .then returns another promise because, in order for .then to finish, it has to wait for the first promise to finish. It has to wait for the get API stories promise to finish. So .then does not actually know how long it will take to do stuff. And so it actually returns another promise. Okay, now similarly, .catch is basically the same thing. It's just, instead of fulfilling the promise, it's when the promise is rejected. So you focus on that, like, let me draw some boxes. That .catch statement, it takes the error, whatever error happened, and then you can, do stuff with that error. You can also not do anything with that error. In this case, the function that I apply, like when my promise is, rejected, is I take the error and I just console log it and say, this is so sad, right? So .then and .catch basically work the same way. It's just .then is when a promise is fulfilled. .catch is when a promise is rejected. And similarly to .then, .catch also returns a promise because it does not know how long it will take to finish, since it has to wait for the original get API stories to finish. All right. Now, a really interesting thing here is, since both .then and .catch return promises, you can do something called chaining promises. So .then returns a promise. So you can do .then again, and then .then again, and you keep doing .then over and over again to do like stuff, at each step. So in this case, we have just some promise function, some function that returns a promise that we call just get promise. Now we have that thing, that promise, .then, and then .then applies some function to it. That function is, it takes the value of like whatever that get promise function did or gave, and then it console logs like, oh, the first promise is done, let's do some more stuff. And then once that one is done, .then, and then it logs some more stuff. Once that is done, .then, it logs some more stuff. Once that is done, you can do .then, you can do .catch, whatever. But in this way, you can kind of chain promises together to do them like sequentially. And this is like you're waiting for each sort of step of the computation to finish. So you don't have to like worry about the promises being promises. All right. Now let's talk about async and await. Now these are two of the most important keywords in JavaScript, at least for asynchronous computation. So when you do stuff with promises, there is one sort of, no, maybe not one, but like there is a sort of tricky aspect to it. And that is when a promise is pending, JavaScript has no idea what the value is. It's just waiting there, right? Like Alan, at his ice cream truck, when he's waiting for the snow cone, he doesn't know if he's going to get a snow cone or not. And in the same way, JavaScript doesn't know like when it's going to get its value or like what its value is going to be. So if you write something like this, so I wrote a function called slow number. So slow number just returns like the input after 1 second. So just waits 1 second, returns that number. And if we just let like, I don't know, const A equals slow number 9, const B equals slow number 10, well, A and B are promises. So they are not actually 9 and 10 right now. They are just a promise that will eventually, we know eventually it will return 9. But JavaScript doesn't know that when it runs that line of code. It just sees it's a promise, it'll get back to me later. So if you actually try to console log A plus B, it's not going to give you 19, because JavaScript will just, see, oh, it's just two promises. I don't know what they are. It's going to log them both, and I'll just show something like this, where it says object promise, object promise. Now that's not very helpful, is it? Because usually we want to, actually do math or do computation or manipulate whatever values we have. So how do we do that? Well, that is where the await keyword steps in. So you can't do computation with just pending promises. So what you do is you just wait for it to finish. Pretty simple. So the await keyword waits for the promise to resolve into some value, and then it just gives you that value. That's all it is. It just waits for the promise to finish, and then it gives you the value. So we can write something like this. So once again, A and B are promises that will eventually resolve into like 9 and 10, but we don't know that right now. And you can just write await and then that thing. So like await A will just say, just wait for A to resolve. So when JavaScript reads that console log statement, there's a console log and it sees await A. So it's like, oh, okay, this is a promise, but I'll just wait for it to finish. So it just sits there until, A finishes. And it sees, oh, A is 9. And it says, okay, 9 plus. It says await B. It says, okay, I'll just sit here and wait for B to resolve. And it says B is 10. Oh, okay, it's 9 plus 10. So that's just what await does. It just waits for whatever promise is to resolve, and then just takes the value that it resolves to. So that's all that await does. Now, it turns out that there is a little interesting thing that happens here. If you actually run this into VS Code, like you just type this thing, or like including the slow number, obviously. But if you run this, it will not work. It will give you an error. And why is that? So you have to look at this concept called asynchronous functions. Now, normally, functions return control back to the caller before once the computation is done. So normal functions return the control back when their computation is done. So if we look at the synchronous function on the left, the blue sort of arrows is like the flow of control in a program. So this is like you're running this line of code, you're running this line of code, running this line of code. You see, oh, I'm calling a function. Let's go over here to the function. I'm going to run this line of code. I'm going to run this line of code, run this line of code. Okay, now we're done. Let's go back, and then you keep going. That's kind of how normal computation works. Well, asynchronous functions are a bit tricky because when you're running lines of code like one by one, you see an asynchronous function. So you start, you do that stuff. But before the asynchronous function is actually done, it'll send control back to the sort of main section that they're calling it from. So that is the sort of key difference between asynchronous functions and synchronous functions. So you can make an asynchronous function by just using a callback function. So the callback function is like the sort of arrow, like the parentheses arrow, blah, blah, blah. That is one way to do a callback function. Alternatively, and I guess more robustly, you can make an asynchronous function by just saying async and then the function. So there's actually a keyword called async that you can just put directly in front of your function definition to tell VS Code or tell JavaScript, this function is asynchronous. And it works with like any kind of function, like async function. It can work with arrow functions, class methods, yada, yada, yada. Just put async in front of it to make it an async function. That's all it is. So in this case, how I wrote slow number was actually I wrote this function, async function slow number, and then it does this thing called sleep. We'll get back to what that is later. I mean, it just turns off. I mean, not turns off, but it just idles your computer for 1 second, in this case, like 1,000 milliseconds, and then returns the number. So that is how asynchronous functions work. Now, the key thing to remember, only asynchronous functions are allowed to use await. You are not allowed, and JavaScript will tell you that you are not allowed to use await when you are not in an asynchronous function. It will give you an error 100% of the time. You cannot use await when you're not in an asynchronous function. Now, what does this mean? If you ever want to use the word await in any scenario, you have to wrap it in an asynchronous function, or else it just won't work. So how does this sort of control and like, well, why is this? I guess that's one thing. And also two, how does JavaScript return this control, passes this control around for asynchronous functions? So it turns out that the await keyword, the way that it actually waits for stuff, does not just sit there and freeze the program, right? So that would be kind of unfortunate if you just, Alan goes, asks the ice cream truck, hey, can I have a snow cone? And the ice cream truck says, okay, he's making a snow cone. Alan does not just sit there like a bot and then just do nothing. He can go around and do other stuff, right? He can like go talk to his friends. He can go have fun, check Facebook, make web lab lectures, whatever. He does not have to just freeze in place while the snow cone or while the ice cream truck is making a snow cone. It would be really unfortunate if you had to wait just for the whole thing to finish whenever you saw an await keyword. So what await actually does is it takes the control back from the function that it's called. So if you call some asynchronous function and you use await in that asynchronous function, now that function is now waiting for stuff to happen. So it's not actually doing anything, it's just waiting. Since JavaScript doesn't like to just sit there idly, what it will do is it'll say, okay, we're just waiting right now. We're not doing anything important. Let's let the main program continue running to do more important things while we sit here and wait for our snow cone to finish or whatever asynchronous task we want to finish. That's what how await returns control back. So every time you see an await statement, the await keyword, it will actually return control to the caller of the function. All right, so when you use await, since you can't use await unless you're inside of an asynchronous function, well, the sort of outer level of the program is not a function. It's just you're just running the program. It's not an asynchronous function. So you cannot use await on the outermost level of the program. In order to use await, what you would do in this case is you just take everything, you wrap it in a function called main, or just whatever you want, and then you slap the async keyword onto that function. Now that makes it an asynchronous function, so you're allowed to use await inside of it, and then you just run the function. So it turns out that JavaScript, what it will do is it will, once it's finished running the program, it will just sit there and it will wait for all of the promises that it has that are currently pending to either resolve or fulfill or reject. So in this case, main gives you a promise, and it will just not finish by the end of the program because it defines this function, it runs the function. Well, main is, the program is done, but the main function's promise is not done. So JavaScript will sit there and just wait for it to finish, and it will run all the stuff inside of it. So this is how you actually use await. Most of the time when you're actually using await in your own projects, you don't really have to worry about this too much because more often than not, you're actually just writing code inside of functions. And so you can just write the async keyword on that. But if you ever are writing code that involves await in just the outer level of the program, you can just wrap it in some kind of just an async function and then run that. All right. Oh, something happened. Okay. What happens if you have multiple promises? Well, let's say you have something like this. So you have 5 promises, promise 1, 2, 3, 4, and 5. They get, various kinds of, they call some API and, they get back the results. But right now we don't know what their results are. So they're just a bunch of promises. And we can just, put these promises in an array like any other objects. You can just put them into an array. And that array we call promises. Now, we can do something called promise.all. So promise.all takes an array of promises and it returns a promise whose value evaluates to an array. So what it does is, instead of having an array of individual promises, it makes one big promise that resolves when all of the little things are done, and it just gives you an array of those values that it outputs to. So it's like each little promise by itself, and promise.all just takes, okay, I'm just gonna wait for all of you to finish, and I'll just give you all of the results when I'm done. So that is what promise.all does. It just gives you all of the results. Sometimes you might need to use something like promise.race. So promise.race takes the 5 promises or just all the promises in an array, and it gives you the result of the first promise that does anything. Did my mic turn off? Okay, it sounded kind of weird. So promise.race gives you the result of the first promise that does anything. Whether it fulfills or rejects, it will give you that result. So the first promise fulfills, it gives you that value. If the first promise rejects, it gives you that error. It does not wait for any of the other promises. Once the first promise is done doing something, once the first promise is no longer pending, and it doesn't mean the first promise is not like promise 1. It's just whichever one finishes first. So once the first promise is finished doing something, it just ignores the rest of them and just gives you that result. So that's what promise.race does. And there's also promise.any, which might be useful. And promise.any gives you any promise, or specifically the first promise that fulfills. So if the first promise fulfills, it will give you that result. If the first promise rejects, it'll be like, okay, that one didn't work. I'm going to wait for the next one. And then if that one fulfills, it'll give you that one. But if it also rejects, it'll be like, okay, that one didn't work either. I'll give you the next one, and so on. So just wait for the first one that fulfills. And if none of them fulfills, all of them reject eventually, then it will reject. That is what promise.any does. And these may or may not be helpful in various situations in which you are handling multiple promises. Okay, now you might be asking, why do we need async computation at all? Like, this is kind of complicated. I don't know why we want this. Well, when you're communicating between different devices, it's like the client to the server to the database, maybe database back, and then the server back to the client. All of this stuff goes over the internet. And the internet is slow, like very slow compared to on your own computer. So you don't know how long it'll take. Like maybe your server is in like, I don't know, Greenland, and it takes like 10 minutes to access it. So you don't know how long this time will take. So all of these sort of steps where you're communicating between different devices, I mean, you don't know how long it will take to communicate. And in that case, you can't just let your computer just sit there idly waiting for it. And so all of this communication stuff happens asynchronously. You're saying, okay, I'm just going to send out my request to the internet, and then I hope something will come back eventually, but I don't really know how long it'll take. So you have to use await, asynchronous stuff to like handle that. Specifically, if you look at the code from like the client to the server, so this is on, or like the use effect stuff is on the client side. So when you do something like get / API stories or post, these will all return promises. And if you actually like hover over them or like look into the actual code in which we have written them for you, you will notice that they will all return promises. And that is why whenever we use any API call, you have to use .then to handle like what it does, or else it just, it'll just give you the promise and not the actual value that the promise resolves to. On the server side, you'll see that, these functions also use .then. So they're also like sort of taking in promises. And like, for example, the story.find, I know this is actually like a call to the database. So like the server calling the database also takes like a while because they're on different devices. So something like story.find also returns a promise or like some asynchronous function. And you have to use .then in order to handle, waiting for it to happen and then doing something. So these are places where you would certainly see asynchronous computation. So all this API stuff all uses promises. If you see like the actual stuff like in utilities.js, which by the way we've written for you, but this is just I think interesting to look at. Like the function get uses this fetch function. It returns like fetch some stuff. It turns out fetch is the actual way that JavaScript communicates from server to client. And that fetch function returns a promise. And we handle that promise with .then and .catch. So .then is like you do some stuff with that, if it fulfills. If it doesn't work, you take that error with .catch and like, you say, oh, there's an error. But this is, just an example of using promises in the client side. Same thing for the post function. It's just the same thing, basically. There's not that much else to it. It also, uses a fetch function or a fetch function. It returns a promise, handles it with .then and .catch. If you look at something like in feed.js in the workshops, you'll see like, all these API calls use .then, blah, 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 in order to do anything. And that's the reason why you have to use .then. On the server side, if you're trying to call something like, oh, I want to access my database, you connect to your database, this mongoose.connect also is a promise because you don't know how long it'll take to connect to the database. So it also uses .then and .catch in order to know, or to do stuff once it's connected or once it failed to connect, because it might take like a little while. On the front end in React, all this like sort of all those like rendering in the front end in the React also is asynchronous, because React will all bundle your code together and it'll like try to run it and like display stuff, and it doesn't exactly know how long it'll take to do this. And so it turns out that all of these functions, like with these sort of callback arrows, are asynchronous on the front end. Although they are like a lot faster than like client server communication and whatnot. Okay, let's talk about something called the JavaScript event loop. Okay, now this sounds pretty fancy, but it is actually just a feature of JavaScript, especially the front end, where it just sort of runs circular and it handles literally everything that happens in like on the front end. So like if you press a button, you like click stuff, I don't know, you like move your mouse around, you like hover over anything, you like make some function calls, like do whatever. All of that goes through the JavaScript event loop. So it's just this invisible loop that is just running whenever you're on your website. Now, if you have an asynchronous function, or sorry, a synchronous function, when you stop to do something, like let's say I'm going to press a button. If I press the up arrow, I want my character to move up. If you write that as a synchronous function, what'll happen is you'll press the up arrow and it'll, wait for your character to move up. And well, in the meantime, nothing else on the computer or nothing else on the website will run. The display will not run. You will not be able to press other buttons. Well, it won't do anything. You won't be able to see anything happen. So it will literally freeze your computer until that computation is done. That's not good. Like when you actually, press buttons on your computer or like do anything, you hope that the rest of the program is like still running. Like you can still move your mouse around. You can still see stuff happen. You don't want your website to just freeze the moment you do anything. So we do something with asynchronous functions. What happens is it sort of branches off of the loop. So the loop is still running, but if you click a button, it'll just call an asynchronous function, be like, okay, do some stuff. We'll get back to you. But the loop is still running. So it can still process, displaying new things. It can process clicking buttons, yada, yada, yada. And, when your character moves up or like does whatever, it'll do that. But for while in the meantime, you can still see the screen. You can still interact with the website. So synchronous functions are not really responsive. It's kind of sad. It's not good. But if you use asynchronous functions, especially for anything that takes a substantial amount of time, like more than 1 millisecond, it preserves that sort of responsiveness. So your website still runs smoothly. So anything that is in background tasks, fetching data, let's say you're downloading stuff or uploading stuff to your website or to a database or whatever, you're doing a big computation, you're, I don't know, generating the first 10,000 digits of pi. I don't know why you would want to do that. You're playing music or a video or whatever. On YouTube or on Spotify, when you click the play button, your music and your video are playing, but it does not prevent you from clicking on other videos or doing scrolling through the comments and typing this video is cool or whatever. The video is playing while other stuff is happening. So all of this stuff is happening asynchronously. So anything all of these kinds of things happen asynchronously to sort of preserve the responsiveness of the website. All right. Now, one last thing. You can actually make your own promises. Now, up to now, we've talked about how do we handle promises that exist with get, with post, with connecting to the server, with doing whatever. How do you make your own promises? How did I make that sort of sleep 1000 function? Well, you can use a special library called Q. It is actually built into JavaScript. So Q lets you make these sort of reverse side. You're the ice cream truck. You can make the promises and keep them. So there is a specific thing that you do here, which is there's an object in the Q library called a deferred object. It's just the name of the object is literally deferred. And you make that using q.defer, which is up there, q.defer, const deferred equals q.defer. That gives you a deferred object. If you want it to or the specific type that you might want it to resolve to, you put inside of the parentheses. In this case, I'm not resolving to anything. I'm just saying, I'm just gonna make a promise that will eventually resolve into nothing. And so I don't have anything in the parentheses, but you can put stuff in that parentheses to make it resolve into something. Now, if you want, so in this case, you use deferred.resolve or whatever your name of the thing is, .resolve to resolve that promise into some value. In this case, I have just used set timeout. Set timeout is actually a function that is built into JavaScript. It's just, it waits for some time and then it does a function. So in this case, I just wait for some time and then specifically the amount of time is in milliseconds. And I do this function, which just says, I resolve this deferred object into nothing. You can resolve it into a specific value, but in this case, I'm not resolving it into anything. And you can return the actual promise by using deferred.promise or that thing .promise. It just gives you the actual promise. If you want other people to be able to use that promise, use async await, use then.catch, whatever, you can use the deferred.promise. If you want to reject the promise, if you there's an error, you can say deferred.reject, blah, blah, you put an error in there. It's pretty much the same thing. And if you want to look at more stuff on deferred or the Q, you can always check out MDN. There is quite a lot of stuff on how to use Q.defer or Q and deferred. But yeah, this is essentially how you make promises and keep them. Okay, so There's a lot of stuff that we talked about, but let's do a quick recap. Promises are the core of JavaScript, asynchronous computation. They have three states. There is pending, which means that you just made the promise, you don't know what it is yet. It's going to end up with something, but right now you're just waiting. There is fulfilled. That means the promise has given you an actual value. Like the ice cream truck has given you your snow cone. It's fulfilled. And you can say it also resolves to that value. Or a promise is rejected, in which case the operation didn't work, it failed. You can handle these promises using .then and .catch. So .then takes a promise, it does some stuff when that promise is fulfilled. .catch takes a promise and does stuff when that promise is rejected. And then you can also chain these together because .then and .catch take in a promise and return a promise. So you can do .then, and so on. You can use the you can use the await keyword to wait for promises to finish. So like you just sit there and wait. And more specifically, JavaScript will pass that control back to the caller of the function while it waits for your computation to finish. You can use the async keyword to define an asynchronous function, just by slapping it on right in front of the name of the function, or like right before the function is defined. And you must wrap every await keyword inside an async function, or else it just won't work. When you use it, you use async when you don't know how long something will take. So communicating between different devices like client server database. If you want to wait for the React front end to like load some graphics or whatever, or like load like what your website looks like. If you want to do any kind of background tasks like downloading, uploading, handling whatever stuff happens in the background, you can do that with async. And then also you can make your own promises using q.deferred, and you can check out more documentation or ask me about it in office hours or something. But yeah, so that is pretty much all there is to it for async computation. So now you should know what this async stuff is, what .then does, and why it's everywhere in our code. But yeah, so I guess one last announcement. Sponsor lectures at 1 p.m. We have Cresicore and Meta. Cresicore is at 1, Meta is at 2. You can come and get some free stickers. They look like this. They're kind of cool and kind of cute. Yeah, and they're free. Cresicore is here in person at 1. And Meta is going to be on Zoom. So, be sure to participate on that. And you might win $50. There will be 4 winners today, like 2 for each. So increased chances of getting free money, which is good. But yeah, so without further ado, we are now officially on lunch.